All right, everyone, this is going to be our first of 3 lessons. I know it's really squeezed, but we got to get through it. We are going to cover 3 things. Simply put, things like perimeter. You don't have to write that. At a certain point, we will talk about area and, of course, volume, because that's between 2D versus 3D. And more so than memorizing a formula, look, you have your formula sheet. I'm not asking you to memorize formulas. You are going to be given interesting questions where you still have to think about what numbers go where. The goal of geometry is not plugging into a formula like a machine. I don't care about whether you can be a robot or not. The point of the geometry lesson is, given a situation that looks very unfamiliar, can you piece your knowledge from other formulas or other sections in mathematics and solve? Okay, and lastly, we have this thing called surface area, not just area, but surface area. All right, so those are the 3 main lessons for this unit. And to do that successfully, I need to do a preliminary lesson on Pythagorean theorem. You don't have to write this down. The Pythagorean theorem is a very, very interesting theory that applies all the time. The idea is this: if you were to create a perfect square with the length of, let's say, A, so this is length A and that is length A, the area of this would be A times A, which is A squared. With me so far? All right. And I take another perfect square based on this length. Get out of here. Right? So let's pretend this is length B. If you take a square with length B, that means this length, the width would also be B. The area of this square is B times B, or B squared. So then the entire area of this square and the area of this square, if I were to merge them together, I would get the same area as this gigantic square. So for example, what I mean by that is, if I had, let's be simplistic here. Think of this as like an Rubik's Cube, right? How many squares do you see in this one? 9. And let's keep it simple. How many squares do you see in this one? And another Rubik's Cube. How many squares? 4 by 4? 16. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25 squares in total. Because I have not 25 squares in total, if I were to count all the squares of this ginormous square, the theory is I should be able to count 25 squares. That's Pythagorean theorem. And as a mathematician, do you want to draw this every single time? No. And so is there a shortcut? In fact, there is. This is why the Pythagorean theorem has this formula and you were supposed to memorize it. Without an explanation, I'm sorry for on behalf of all the previous teachers you had, right? But the idea was this: if I have a 3, what is the area of this square? 3 times 3, which is 9. Okay. If this length was a 4, what is the area of that square? 16. 4 times 4. So 9 plus 16, I should have 25 squares here. And if that is a 25, the number is 25, what are my lengths? It's got to be 5 times 5. Hence, 3 squared plus 4 squared gives me 5 squared. Hence, the length squared plus the other length squared gives me the longest length squared. That's Pythagorean. And for you to not know any real math and come up with this theory is pretty spectacular. For you, it's not a surprise because you've been taught it, you've been told it. But someone discovered that, this relationship, and it happens every single time. So here's a couple of examples, just again, very, very quick. If I had a right angle triangle, it has to be right angle. This was, let's say, 3, and that was 5. What is that length? Well, I know that a squared plus b squared always equals c squared. What number is a? Yeah, sure. So it's 3 squared. And what number is b? 5 squared gives me the hypotenuse squared. I'm going to do the math very quickly. 9 plus 25 is equal to c squared. Add it together, 34 equals a c squared. So that means c must be square root of 34. Just for the sake of numbers, let me do that in the calculator. C is 5.83 approximately. That hypotenuse is 5.83. Pythagorean theorem. What's interesting, we can do the flip of it. 1 second, let me just try to move this aside. Oh, okay, sorry about that. Okay, I could do the flip side. How about I give you another triangle, and this time this is 8, and this is 20. What's that side? Once again, a squared plus b squared equals c squared. In this case, what length is side A? Match the picture? Yep, okay. What is side B? Nolan? Pardon? Minus squared? Oh, 20, careful. Here's what I wanted to do this example for. C is always going to be the longest side. In fact, do we know the length of B? No. So we're going to leave that alone. C must be that longest side that is opposite of the 90 degrees. So this 20 is actually here. So doing the math, 64 plus an unknown number squared equals 400. How do I get b squared all alone? There you go. 400 minus 64, we get 336. That means b is a square root of 336. We have 18.33. That length is 18.33. This is supposed to be prior knowledge. In other words, if you think the Pythagorean theorem might help you over the next 3 days, even if I don't tell you, you are free to use it. It's something that everyone sort of expects you to sort of know because it was probably drilled like crazy in elementary and middle school. If it wasn't, I hope that you'll be able to use it on a whim. If I say, Pythagorean theorem might help, I hope you know how to use it. Here's an example where you did not know the hypotenuse. Here's an example where you did know the hypotenuse. You have to be careful where the unknown value is found in the equation. Any questions? No? Okay. Whew. Let's do it. Let's see how much you know about vocabulary. Moving on to our actual sheet for today, and I will try to pick out the ones that are most useful for your studies. There we go. Perimeter, in your own words, is the distance around what of a shape? Yep. So if I were to ask you, what's perimeter? What would you say? Right? Yeah, the distance around the outside. Okay, I'm going to say outside or the outer edge. And then on the flip side, area is the number of squares, the number of actual squares, square units contained within, inside. Right. You might remember in elementary school, shapes like this was given on a grid and you had to count how many cubes were inside it. Do you remember that? And that was so annoying because some of these areas were like not accurate and it's not right on the line. And you're like, I don't know what that's supposed to be. And the teacher says, estimate. And you're like, screw this. I get it. I understand. I don't like it either. But we're not counting anymore. We are calculating, unfortunately. Now, did you have a question? Yeah, I thought you had your hand up. Okay. Let's do it. Determine the perimeter and then the area of each of the following shapes. You could use the formula sheet, but I'm going to try to gear you towards figuring it out on your own. Okay. The formula sheet for this shape, aka a parallelogram, says that it is supposed to be B plus B plus C plus C. I hated formulas. I needed to understand why when I was younger. I'm still like that today. And I think that attitude actually helped me grow as a thinker in mathematics. And so I'm going to try to push you towards that. Knowing that this perimeter is the distance around the outer edge, that means I walk this way, I walk this way, I walk this way, and I walk this way. How long is this edge? 15, sure. How long is this edge? How did you know that? So how do you know that they're equal? Good. There's an assumed property in parallelograms. A parallelogram means that the opposite sides are in fact equal and they are parallel. So that is also a 15. So instead of memorizing a formula, if you know that the perimeter is just the sum of the outer edge, I think everyone here can simply look at a picture and do that without needing to look at the sheet. What do you think? Right? And I want you to have that same mentality every single time, no matter how hard it gets. Here we go. 15 plus 7 plus 15 plus 7 is 44 centimeters. Units are important. What about area? Some of you at this point are like, I don't know, I'm going to look at my formula sheet. We can do that. What does that formula sheet say? It is length times width, but what's the length? That's for the long side, 15. But what's the width? It's not 7, it's a 5. The question is why? The answer is 15 times 5. But why are we doing 5 instead of 7? Yep. You're right, but why does it make sense to do 5? You're essentially shifting it. Here's the argument. Around up here. Yeah, everyone. Here, let me erase this. Does everyone see this portion? You have to assume that that dotted line is perfectly vertical, okay? Does everyone see that? Literally, take scissors, cut that dotted line, and bring it to the side. What did I create? A rectangle. And what's the area of a rectangle? Geometry, it has nothing to do with memorization. Every single formula you see here on this sheet is based off of manipulating like this. Once we get to 3D surface area and volume, you're going to have your mind blown. At a certain point, you're going to be like, this is way too much thinking. I'm just going to memorize a formula. But other people I know appreciate it. I remember doing this for a grade 9 student, and they were so surprised how much logic went into these formulas, because all his life up to grade 8, he simply just listened to his teacher and hated math. And now he's thinking of, you know, he's really into aerospace dynamics, and he's really into physics, and I don't know, it's crazy. Not saying it's my fault, but I just want you to know that people are like, oh, there actually is a thought process behind it. And I hope you get there too. Okay. All right. So that's why if you were to take this as my actual shape, the amount of shape that you see in the white is the same as the darker gray. And so I'm still counting the same number of squares. That's my cheat method. I'm cheating, so to speak. That's why we say the length is 15. The height is a 5. So 15 times 5, my final answer is 75 centimeters squared. Yes. Well, yes, base times height, correct. Let's continue on. The circle is pretty straightforward. Again, you can just follow the equation if you want. It has to deal with limits, so I unfortunately can't tell you where the cheat method is. It needs calculus to do that. That's grade 12, in my opinion. I'm going to go to letter C. What is the perimeter? Again, you could look at your formula sheet and try to memorize the formula. But let's pretend this is not there. What is the distance around? What would you add? Yep. So just give me the numbers. Okay. Plus 7, plus 7. Good. It is, right? 20. Oh, let me use that thicker. That's 20, 10, 7, 7. The distance is all around. And if you add that together, correct, you would get 44 centimeters. Okay. Some people, everyone, take a look at the formula for area. What does it say? It says this: top length plus the bottom length. In other words, the two parallel sides, right? Top length of bottom length, A plus B, multiplied by the height, all divided by 2. What? Why? Why does it do that? Before I move on and do all the other questions really quickly, this is what I mean by you have to think about it. Everyone, I'm going to erase this height. Does this remind you of something? 2 numbers added together divided by 2. Going once, going twice. Nate?
It's the area.
Careful. No, this part. Top plus bottom divided by 2. 2 numbers added together and divided by 2. It is an average. It's an average. Yeah, you're right. Absolutely right. It makes them the same. Here is the logic behind it. If I have 10 here, let me do this quickly. If I have 10 here, and if I have double that, 20 here, I have a rectangle or a square with 10, or a rectangle and 2 triangles. But instead of doing it that way, here, let me try to, you know what, let me backtrack. I don't like that visual. Let's put it this way. If I have this triangle, I could technically, can I not, cut this portion in half? And can I not bring this portion and bring it up to the top to create a rectangle? What do you think? Does that make sense? I'm going to cut that little piece and create a rectangle. Same with this triangle. I can take that piece and I will cut that part off, bring it to the top so that I have another rectangle. All of a sudden, what do you notice? I have a normal length times width situation. If I were to take this bottom length and I take this top length right here and I average it, I will get a length that is, well, averaged between those two. And I'm, again, manipulating and creating a rectangle so that I can do length times width or base times height. So there is a logic to everything. Again, it might be a little hard to wrap your head around it for now, but using that as my defense, my top number is a 10, my bottom number is a 20, I multiply by the height, which is 8, and then I divide it by 2. I average the 10 and the 20 to get me my length. I multiply by 8 because that's my width. I get myself, let's see, 30 divided by 2, that's a 12 times 8, that's 120 centimeters squared. Stopping right there. Any questions? No? It seems straightforward. I'm going to jump a little bit to show you how we can use this information to work backwards. At this point, you may not want to think about formulas as a logical argument. You might just want to use a formula in itself. But we'll see. We'll see how far your own personal knowledge will take you. Please turn to the back of the first page. We're going to do the very last example together. Here's one example where you are asked to manipulate a rectangle. I will draw the rectangle. I am a visual person. I really like it when I don't have to imagine it in my head if I don't have to. A rectangle has a length of 5.5 centimeters, but the area is 16.5 centimeters squared. Determine the perimeter. If I want the perimeter, what sides do I need? Yep. All 4 sides. Therefore, I have 5.5. This is also 5.5. I need the widths. So this question is basically saying find width, but without saying find width. Does that make sense? Go for it. Go for it, Arvin. 16.5. Why? Give me the formula first. Good. So base times height, or of course, length times width, whatever. And what numbers do you know?
So the area is 16.5.
I'm plugging in 16.5 here.
Base 5.5.
I'm plugging in base of 5.5 here. Height. Good. The reason why I'm asking for the formula is because I want you to show me all the algebra. H is good, which gives you 3. There, my height is a 3. That's a 3. That's a 3. Therefore, Finish the question. Perimeter is 5.5, sorry, 5.5 plus 3 plus 5.5 plus 3. That is 8.5 times 2, 17 centimeters. Please be warned. It doesn't matter if you simply copy, because you may not get this exact question ever again. However, your goal is to understand that you will be given parts of an equation, parts of a formula, and how you manipulate is going to be challenged. Your ability to think for yourself is going to be challenged. That's why certain people hate this part of the course. They're like, just give me the X and I'll find you a Y. Let me just plug into an equation. I can do that. Geometry is all based on, can you think for yourself? What do I mean by that? Well, jumping straight into a composite figure. Going to the next example. If you already see that different shapes could be pieced together from smaller shapes, this unit is going to be so easy. But if you're having trouble with that visual aspect, hey, you got to keep pushing. You will get there. Keep working on it. All right. Composite figures are figures that are made up of multiple simple shapes. Here's an example. What shapes are present in the left shape? Simple ones. Michael? Huh? Where? At the top? Good. If this was a piece of paper, you could take scissors, chop that part off, and you have a nice, what it looks like, an equilateral triangle. Another person, please. Right on. Yeah. So if I took scissors and cut this off, I would get a semicircle, leaving us with a rectangle. So if I were to ask about things like area or perimeter or whatever, that means you need to be able to calculate information of all three types of shapes and then bring it together. Let's try it as an example in just a second. Okay. What about this one? What shapes do you see? Triangle, upside down, yep. What else? Yeah, another triangle?
Yeah, on the right.
Possibly like this, or maybe like this, like this. Sure. Let's keep it simple. You don't have to go in, you don't have to chop it up that much. Yep. Right. Sure. Maybe there's another thing here. Here's what I see. I actually see the exact same shapes as the one on the left. But instead of adding onto it, we've cut it out. It's the same shapes, at least as far as I can tell. So describe the similarities and differences between figures 1 and 2. Here's my take on it. Both have the same simple shapes. Figure 1 has 3 shapes adding to each other, whereas figure 2 has the circle and triangle subtracting from the rectangle. See if I could make that into a little bit bigger. There it is. Okay, everyone take a look at these two shapes. I have a question for you. This will really challenge your visual and critical thinking. How do you think their perimeters will compare? assumption. The circle on the left and the circle on the right are the same circles. Okay, I hope that you don't get confused. Like this part right here, let's pretend it's the same as that, okay? And this triangle here is the same as that triangle here. And this rectangle is the same as this rectangle. Okay, removing that from the possibilities, what can you tell me about the perimeters of both shapes? Perimeter. I'll give you 10 seconds. Think about it. And be wrong. I invite you to be wrong. Once or twice. 50-50 chance. Is the perimeter the same or is it different? At that hint, I think a lot of people might have caught on. I heard something? Yep. Why? It's either going out or in, but the distance you walk is the same. Consider this. You can't see this in the video, but I'm going to take two fingers like I'm people here, okay? I'm going to start on this right edge, okay? I am walking, 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 walking. Same distance so far? Walking, 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 walking. Same distance so far? The only difference between here and here is the direction, but the distance is the same. Walking, 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 walking. Get it? Same distance. Okay, so it's a lot. So you might think like that's weird, but if you think about it, that's the challenge that I'm giving you. Geometry is not just plugging into a formula. You gotta be. I'm challenging you to notice these things, right? And if you can use your savviness, use your critical thinking, you can probably manipulate shapes and distances and areas and whatever to make questions even easier for you as we solve it in the future. To be able to make those decisions on your own and be confident that you're doing it right is going to be the biggest challenge of this unit. All right, so let's try it. Yes. Okay. And I actually don't have something. I wanted to lead my lesson into a slightly different angle than just trying to find a conclusion. To find a perimeter of a composite figure, I need to blah, blah, blah. I want to diverge from these rules. I want you to make your own decision on it. Okay. So let's try it. Same with area. Okay. Same with area. For this one, obviously, as I said before, these pieces are adding on to each other. So the area you're going to have to add on. These two parts we're subtracting from each other. So you're going to have to subtract area. But all that stuff, again, like I'm going to leave this part blank. I'm not interested in it. Let's look at some examples. Okay. To end today's lesson, I'm hoping that we'll be quick with example here and then an example here. Right? The last one, well, that's my challenge to you. And the remaining pieces, I'm going to see if you can do on your own. Ready? Determine the perimeter and the area of the following shape. Now, I think maybe we forgot to put in some numbers or the numbers actually got cut off. Let's say that this is 10. And you will say that this work. Sure, let's do that. Okay, I just made up these numbers. I think we forgot to actually put the numbers in here. The top edge is a 10, the bottom edge is a 3, and we have 4 here. These two sides are made to be identical, and so you know that this side is going to be a 10. Perimeter. Do you notice that there is no formula for a shape like this in your sheet? So you're gonna have to do your own thinking. How do you find the length of all the edges around? Well, I know that this is a 10. I know that this is a 4. So what's left over? Yep. Yeah, right? So this is 10 minus the 4, that is equal to a 6. Good. In the same way, the far edge is a 10. This short piece is a 3. That means this length is 10 minus 3, it's a 7. So let's clear this up a little bit. Yep. I know, that's why I drew it in. So let's do it. Perimeter. Ten. So 10. 10. 6, 7, 4, 3. 6, 7, 4, 3. 40. Wait. What? Really? Isn't 40 the same as 10 plus 10 plus 10 plus 10? Coincidence? No. You can't see my fingers on the video, but again, 2 people, right? 2 people. Same distance? Same distance? Same distance? Same distance. Do you see it? Whether I walked 7 and then 4, or if I walked 4 then 7, it's the same distance. Right? So there it is. There's perimeter. Again, you could think about it as coincidence. You can use this knowledge to your advantage. Or if you're not interested, that's fine. Section it off? Well, not for perimeter. That would sort of, yes, for area we will. So I'm going to actually bring this out. Let's talk about area now. For the area, we want to know what that entire space is. So there are a couple of ways you can do it. I just talked to you about this big piece here. What are some ways you can do area? I think what Manny is going to do is, let's cut this up. Or cut it up. So I've got this long rectangle right here, and I've got this smaller rectangle over here. Let's do some. Okay, so this is version 1, okay? This length is a 3, and that's a 10. So that's 3 times 10 for the first rectangle. And let's add this smaller piece, 7 times 6. So that's 30 plus 42. This is 72. Anyone have another idea? Be creative here. Yep. What do you mean by other way? Oh, true. Yeah, you can do this and you'll get the same answer. Anyone thought about a different way? Yes. Remember this part? This part we're adding pieces on. This part we're subtracting pieces. So what we could do instead, take a look. I'm going to figure out the area of this big piece, and then subtract that small piece. Right? No, it doesn't. That's the beauty of it. And that's why a lot of students hate this, because there's more than one way. And they're like, just tell me how to do it. And I'm like, it doesn't matter how I tell you how to do it. It matters that you can reach that on your own. It's about being able to think for yourself. So 10 times 10, and that is going to be subtracted by a piece that I cut out. This is 7 times 4. This is 100 minus 28. And surprise, I get 72 again. Yes, no? Depending on the circumstance, one method might be easier than the other, depending on what information I give you. But either way, it still is correct. In fact, that means you're thinking if you do it ways that I don't ask you to, but it still works, right? Last example before I let you go. And this one I think is a little harder. When you turn to the next page, they will give you a rectangle with an interesting piece cut out. If you think you can handle this and think for yourself, then do it without me saying. But I will run through this example with the class. I'm going to give you a minute and have an idea of how you can calculate the amount of fence required. In other words, am I talking about perimeter or area? The amount of fencing I require for this field. Please find the perimeter of this shape. And there is no formula. You have to figure out what parts of different simple shapes you might need. And here's a hint. There you go. There's your hint. I'm going to give you a minute just to get started. You may not have to finish or may not be able to finish, but get started. Not to waste too much of your time, I'll go right into it. The question is about perimeter. So take a look. I've got 10 kilometers, 7 kilometers, 6 kilometers, and 3. The only thing I need to know is what is the distance of this curved area. And if I find that out, well, I can add all of them together because I know that's what perimeter is. Question is, how do we get that? My hint to you was that this curvature, being a perfect curvature of a circle, we can pretend that this is a simple circular shape. And using our formula sheet, you can figure out what the distance around that entire thing is. Why does that help me? If I can figure out the circumference, how does that help me? Yep. Okay, so how does that help me? Okay. So you know what this radius and that radius is, sure. But how does that help me find the curvature, the distance? No, the diameter is this. It's going to be a little different. If I found the circumference, in other words, the distance around the entire circle, how does that help me achieve my goal for perimeter? Why does that make sense?
Because it's a quarter of the circle, so if you divide that 4, you get a quarter of the way around.
So the applied assumption, very good. The applied assumption is that from here to here, the distance that I covered is exactly 1/4 of the entire circumference. So if let's pretend this is like 100. The distance around the circle is 100. That means it must be 25 plus 25 plus 25 plus 25. So we can divide by a 4. Circumference requires your knowledge of a formula 2 pi r. That's from your formula sheet. Correct. So what is my radius? Radius is the distance from here to here. Elliot?
It's 4.
It is 4. How did you get that?
Because, sorry, excuse me. 10 going across the top, assuming that the top, like over there, is going down to the center.
Yes.
Then 6 going across.
Good.
10 minus 6.
Perfect.
Also 3 minus 7 is also 4.
Correct. So 10 is here, and we assume that this length is going to be 10 as well. That means it must have been 6 plus a radius of 4. Same thing with the 7. If you chose this way, then we can assume that from this point to the corner, the imaginary corner of my rectangle is a 7. So 3 plus 4 gives me that 7. So my radius is a 4. So
I have another question.
one sec. 2 times pi times 4 gives me 8 pi, which is approximately.
Yeah, that's my question, was how much do you round down and things like that? I would 6 point.
Preferably, don't round at all. But in this case, when you want to present it, it does say round to 1 decimal where necessary. So here is my circumference. 25.1 is my entire circumference. So what is, I'm going to call this length, or you know what, C for curve. If the circumference is 25.1, what is, let's call it A for arc. What is the length of the arc? 6.275. So I'm going to round it to
6.3, that's right.
6.27. Yep, 6.3. All right. Then my perimeter is, let's add it all together, starting from this top left corner. We've got 10, and then a 3, and then a 6.3, and then a 6, and then a 7. Going around, 10, 3, 6.3, 6, and then a 7. My final perimeter is 32.3 kilometers. Yes.
If you would need area, would you divide the area by 4 and you know what the perimeter?
Yes, exactly, exactly. Good for you. Yeah, you got to think for yourself that way. You're right. Just to let you know, what if the question actually asks for area? What if it asks for area? What would you do? Well, first, I'll do it in pink. First, we will get the area of this entire thing, and then take away 1/4 of the area of a circle. So going back to what Nolan was asking, like, does it matter which way you do it? And I said no, but let's pretend you actually cut this shape because you want to add pieces together. Do you see how this part could be very difficult to find area for? So there are certain situations where taking away or subtracting is definitely easier than cutting up and adding together. I recommend you find the area of this rectangle and then find the area of this circle. Good. Find the area of that circle and then divide it by 4 and then subtract from the pick. Everyone, this section is not about the formula. It is all about thinking, which means you will need the practice. It has nothing to do with, well, it does have everything to do with the right answer, but this unit, you need to practice that thinking aspect. You will not be able to fake it till you make it in this unit because it's really not about the final answer. I am interested in how you got to that final answer. I am interested in whether you decided to take away or you decided to add in, how you found each piece. So practice that, please. Okay? I have a lot of examples that I did not do, but I think that's going to be good homework for you. See if you can spend the next couple of minutes trying maybe question B before the bell rings today. All right. And also, as a reminder, I guess I'll stop the video. I want to remind you about the math presentations.